So hi everyone. I'm going to sit down in a second because the microphone for the video is down here. Yeah, so I am at the moment just working at a small company. We've written most of our web services in Go, and this is kind of just to talk about some stuff that if you're using Go day to day, you'll probably know. But if you're kind of new to Go, then there's some interesting features, and we're going to have a look around the standard library as well and just see some different uses of interfaces that are used there. So yeah. Sorry, just speak up a little bit. Okay, sure. Okay, I'm going to sit down now. So who am I? We've done that already. We're working on forum software, which is all built on web services. The back end's all Go, so the front end's open source. Anyone makes it. So.
Can you speak up?
Okay, is that loud enough?
Just pretend you're shouting at someone if you're really angry.
Okay, I've got water, so it's be okay. So the reason I want to talk about this, there's a couple of, well, there's one kind of specific feature about interfaces in Go which make them kind of interesting. Obviously, interfaces exist in many different languages, but the way that you can use them in Go is kind of interesting. So that quote there from Russ Cox is really, that's one of the articles actually that he's got on his website, which is worth reading about interfaces. So just to recap, I know that many of you here will already use Go, but for those of you that don't use it all the time, so this is just a very simple interface called stringer. It has one method there which takes no arguments and returns a string. And we have a type, a struct type complex, and we have the string method defined with the receiver of type complex. So you can see there that I've just overridden what you can, what it returns. So when you call the format.println function and pass a type of complex to it, a value of complex, then it will print that format string. So string is used all over the standard library. It's probably like, I don't know, 50 types at least implement stringer. As you can imagine, it's pretty useful. So, yeah, so that's just an example from the standard library for the default kind of format for printing a timestamp. In Go, you pass in a format string rather than the actual format statement. Okay, so what makes interfaces a little bit more interesting in Go is that they're implicitly satisfied. So you don't have to declare that a type implements an interface. It happens just by virtue of you implementing the right functions, the right method set. So one of the consequences of that is that if you have some code that's provided to you, either in the standard library or third-party code, you don't actually have to modify its implementation in order to create an interface and have it implement that. So one of the examples, good example of this is database SQL. So when we started out writing our code about a year ago, I was kind of going through the different packages, looking at how we're going to talk to the database, how we're going to do the serving and everything else. And I found that the actual dependency for talking to the database, this type DB in the SQL package, is a struct type. There's nothing wrong with that. It just means that it means when we want to swap it out for something else, you need to kind of either use a different type or entirely, or you could wrap the whole thing in an interface, which is effectively what I did. So I made an interface type. I called it DBO, which is a terrible name. Don't call it that. And it has the same method set as the struct type. So by virtue of it having the same method set, SQL.db implements that interface. And so in some places in our code, where we pass in a database dependency, I just replace the instances of that with this interface. So the actual interface type, which I made, is here. It's it's a big interface. I mean, most of the interfaces that you see in the standard library and various other bits of code usually have one or two, maybe three methods. This obviously has quite a few. But these are just the the method signatures that the DB type has as a receiver. So in a place where you might use the DB type, this here is just demonstrating that you can use the interface type. So the DB variable at the top is a value with the interface DBO. And you can see that I've first of all opened a connection to SQLite just to demonstrate that you can use it as a receiver there. And calling ping, which does nothing interesting, it just demonstrates that you can call ping on both types there. And then a satsdb, which is again a terrible name of mine, which is just demonstrating that you can use that in place. I didn't bother with an open function because generally whenever I wanted to use that, I would do the setup somewhere else and then I'd pass in the database dependency. So I mean, that's one way of doing it. You may not want to do it that way. It's kind of, if you're doing that much kind of code modification just for sort of testing and that sort of thing, then you maybe want to do it a different way. But even so, it's kind of an interesting thing that you can do. So if you are actually trying to test your database code, then there are other options you should probably look at. So somebody's gone and actually implemented a test driver. I think probably Brad or whoever worked on the SQL code. There's actually a fake driver which has kind of SQL-like queries that you can make, and also there's some test packages as well. So anyway, that's not totally related to interfaces. So I kind of I started writing Go code about a bit over a year ago, and then about 6 months after that, I started looking at the contribution, and kind of because there were a few things that I was curious about. I wanted to see how some of this stuff was implemented. There was some open bugs on stuff like tests and documentation that I thought I'd help out with. So this is the next part of this talk is kind of just looking at how interfaces are used in parts of the standard library. So there's a couple that we're going to go through. The first is the encoding interface, which appeared in Go 1.2. The actual work was done about 6 months ago or so, but obviously it shipped in December with Go 1.2. And the other one is in the driver code for databases, for SQL databases. There's a couple of interesting sort of interfaces there, which are used to map values into database types and vice versa. So I think I've just said all that. So it's new in Go 1.2. So it supports two kinds of marshalling and unmarshalling: binary representations and text representations. So it's used in a couple of places in the standard library as well, as you can imagine. So let's have a look at one of those, or two of those interfaces. Marshalling and unmarshalling text. So as you can see, the text marshaller interface has a single method there, which returns bytes, obviously UTF-8 encoded. And text unmarshaller goes the other way. So it takes some bytes and it will fill out your object for you. So the interesting thing about these is that there's no reference here to JSON or XML because they can actually be used for both. So if you define these things on your own types, then if you want to produce multiple representations, JSON or XML, then these are reused in the same way. So you don't need to go and override each handler for those things. So an example from the standard library, the net.ip implementation of it. So IP is, the type is just an IP address, it's nothing else. So here you can see the marshal text implementation. it returns some bytes and an error if there was something wrong. So pretty straightforward. And the other way is essentially passing an IP address from a string and filling out the object if there was an error. So the JSON encoding decode will check for these interfaces. I believe the XML marshaller will do that as well. And one that we haven't looked at is the binary marshaller and unmarshaller, which do, as you can imagine, analogous things. And that's used in the GOB encoding. So, yeah, so if you want to define custom serializers for your own types, then these are the kinds of things that you can do. I mean, obviously, I've never used a JSON encoder where you couldn't override the marshalling for your own class, but this is kind of a pretty lightweight way to do it. And if it can be reused across multiple representations, then that's even better. So moving on slightly. So I'm not sure how many of you have used the database package, but essentially the Go database SQL package does quite a bit more than in most languages I've used. So it will do stuff like handle connection pools, and so connection pools, and also translating some types from database types to Go types. So actually, some of that stuff can be done in the driver as well, but the actual connection pooling is done in the Go standard library, not in the database driver that anyone can write. So internally, these two interfaces, scanner and valuer, are essentially, well, as you can see, assigning a value from the database driver into a Go type, and the opposite, taking a Go type and going, what do I need to put into the database based on this Go type? So, yeah, so those are used all over the place for the various inbuilt types. But this is an example from libpq, which is the Postgres driver for Go. So I'm not sure how many of you have used Postgres or HStore. HStore is basically a key value store in a column. It's a column type. So if you decide that using a classic schema is too restrictive, then you can go ahead and just make a bag of attributes. So as you can see, what this does, to take a HStore type, a struct type, and insert it into the database, it says, well, okay, if there's no map, then just return nil. But if there is a map, then take for each, so range over the whole map, and for each of the keys and values, build up a statement, which is basically a string, key, and then right arrow to value, and append that to the parts. And that's basically the statement that needs to get executed to insert those keys and values. So yeah, I mean, another example I saw doing this was gzipping data. So you could gzip some column type if you wanted to, and then obviously if you want to use it in Go, then you need to unzip it before you use it. So yeah, so I said about 6 months ago I started digging around the source code and just looking at things in a bit more detail. There's a tool called Go Oracle, which makes a lot of this extremely straightforward. So I'm going to try and do a small demo. I'm not entirely sure how well it's going to work on this screen. If I mirror. Okay, everyone can see that. That's good. So Go Oracle is actually it's not part of the toolchain, but it is a command line tool for Go, and it basically it uses the AST package, but it basically analyzes the source code. It works out things like which interfaces does this type implement, what is the call graph for these functions. So a bunch of really useful stuff, and it's very easy to use with this web browser front end, which is called Pythia. So we're in the HTTP server. So we're in the HTTP server code at the moment. So earlier on, I was looking at I think I was looking at servmux earlier. So if I go to the servmux struct here, I can describe it. It tells me the method set that servmux has. So we can see here that it implements serve HTTP, which means that it's a HTTP handler in Go terms. That's another interface. So I should be able to see. Yeah. So there we go. So this implements HTTP handler. This is extremely useful. I think if you're new to Go, I think it's probably pretty useful because there's various read, write, recloser, various interfaces for that stuff. None of them are complex or difficult, but they are used in various places. So it's kind of nice to see where they get used. And also, I use this every time I look at a new code base now. If it's more than a few files, then I'll probably just fire this up and start using it because it makes things a lot easier. And because it's a command line tool, I think somebody's already done Emacs integration for it, but there's probably going to be a Vim plugin for it at some point. I'm not sure where people are on that. So let me just take that down. So I think, we've come under time a little bit. But basically, the references, so there's a few things that you probably want to take a look at. So there's a really good example of using the image package, actually, and adding, so Go comes with, I think, at least JPEG, PNG, and GIF at the moment. Probably a couple of other types as well. But basically, it's very easy to create a new decoder for images because of the way that the interfaces are structured. And you basically just define your decoders, define a few things like how to fetch the particular bitmap value at a particular point, color value. And then you can use that to, you basically just register your new decoder, and that's all you have to do. The article at the top is Ross Cox wrote a really interesting article on some of the implementation. So, as you probably know, if you've used Go already, when you compile, the interface types are checked. So you do get nice static. You know about interfaces at compile time, but obviously some of it's done at runtime too. So the actual method resolution is done at runtime. So there's a good article on the internals there. And pretty much source code. Go and read the code if you can. It's really, really readable. It's extremely well structured. As somebody who didn't look at it at all 6 months ago, and now a decent grasp of the major packages in the standard library at least. And the other stuff is from PQ, which is interesting to read actually, because like I said before, the SQL package does a little bit more than it does in many other languages, so that obviously impacts the way that you write your driver, and how you do things like connection pulling and that sort of thing. So I think pretty much there. So have people got questions or?
Any questions? Great. Okay. Thank you, Matthew.
Cool.
So we actually have a short break.